An alpha particle of charge plus 2e and an electron move in opposite direction from the same point, each with a speed of 2.5 times 10 to the 5th meters per second. Find the magnitude and direction of the total magnetic field this charge is produced at point P, which is 1.75 nanometers from each of them. Now here we have two charges, one positive, one negative, moving in opposite directions. Each one of these charges creates a magnetic field at point P. This magnetic field can be calculated as mu0 over 4 pi multiplied by the charge q, cross product between the velocity and the unit vector r divided by r squared, where r represents the position of the point where you calculate the magnetic field with respect to where the charged particle is. The unit vector r, don't forget, is along the direction of the position vector for the point where we need to calculate the net magnetic field, as you can see in this case here. The magnetic field created by the alpha particle is oriented out of the page, according to the right-hand rule. Orient the four fingers of your right hand along the direction of motion for the alpha particle, to the right, and wrap the fingers across in such a way that you align the four fingers across the unit vector r. As you can see, the thumb comes out of the page, and that will be the direction of the magnetic field created by the alpha particle. The magnetic field created by the electron is also oriented out of the page. The right-hand rule, though, gives you a direction into the page. But don't forget that because this is a negative charge, we actually have to switch the direction for the magnetic field. Now all we have to calculate is the magnetic field created by each particle and then add them up because they're oriented in the same direction to find the net magnetic field. The magnitude of the magnetic field created by the electron will be equal to mu0 over 4 pi multiplied by the charge of the electron, which is e, multiplied by its speed v, multiplied by the sine of the angle between the direction of the velocity and the direction of the unit vector r. As you can see in this case, this is 140 degrees angle, but that's not the angle between the velocity of the electron and the unit vector r. That angle is 180 minus 140 degrees, divided by r squared, where r represents the distance from the electron to point P. The magnetic field created by the alpha particle is mu0 over 4 pi multiplied by the charge of the alpha particle is 2e multiplied by its speed multiplied by the sine of the angle between the speed of the alpha particle and the unit vector r, and that angle is 140 degrees, divided by the distance from the alpha particle to point P, which is the same, r squared. The net magnetic field will be the sum of these two magnetic fields, and that gives me an equation that looks like this, where I have forced out mu0 4 pi e and r squared and v because they are all the same. And in parentheses, I am left with sine of 40 degrees, 180 minus 140, plus 2 times sine of 140. Don't forget that you have a 2 here. All we have left to do is plug in the numbers. The magnetic constant is 4 pi times 10 to minus 7. The charge of the electron is 1.6 times 10 to minus 19. The speed of each particle is 2.5 times 10 to the 5th meters per second, divided by 4 pi. The distance from each particle to point P is 1.75 nanometers, which is 1.75 times 10 to minus 9. And don't forget to square this, multiplied by sine 40 plus 2 times sine 140. Using a calculator, you get that the value of the magnetic field at point P created by the electron and the alpha particle is 2.52 times 10 to minus 3 Tesla.